Timber Talks is brought to you by Wood Solutions. Stay up to date with the latest in timber, the building material that is strong, safe and sustainable. Here is your host, Adam Jones.
Michael Green founded Michael Green Architecture in 2012 with a big focus on advanced wood buildings. So Michael is best known for his research, his leadership and advocacy for timber buildings, and is the author of Tall Wood Buildings and has multiple TED Talks that have clocked up hundreds of thousands of views. Now in this episode we discuss what are some of the biggest problems facing construction and what are the opportunities with automation and robotics, and why his firm Michael Green Architecture has recently paired up and joined Katerra. Now I feel very, very lucky to be able to speak to Michael Green. I hope you all enjoy the show as much as I did speaking to Michael, and without any further ado, we'll get into the episode.
Sure. I'm a Canadian, grew up in Canada, but ended up going to university down in the U.S. And I ended up working for an architect named Cesar Pelli. And Cesar's practice still exists today, but is a global practice doing a lot of the tallest buildings in the world. And I did that for about 8 or 9 years before moving back to Canada. And it was pretty important because it was a chance to kind of see a window into how big buildings kind of shape skylines, but also shape imagination and innovation. And that experience, I think, was really important to where my sort of opportunity and career evolved to. So after being down there in the States and moving back to Canada, really it was a chance to kind of return to the Canadian forests and I moved to Vancouver, where of course we have these amazing trees and amazing forests. And pretty quickly my architectural interest kind of returned to building in wood. And I started a practice in 2003. I started a practice with a partner. In 2012, I separated that practice and started MGA, which at that time in 2012 became an opportunity to really say that the practice would focus 100% on advanced wood construction and wood construction in general, but certainly with a huge focus on what we call advanced wood construction. And that's been the sort of history that brought us to today. So really MGA is only a 6.5-year-old, coming up on 7-year-old firm. But it's been a really wonderful ride of this wave of the increase of wood, not just in North America, but globally, and interest in wood buildings.
Mm. Looking at your TED Talk that you gave in Vancouver, you mentioned how there's two big world challenges at the moment facing construction, and one was world housing and the other was climate change. So how do you see wood construction really helping solve these problems going forward?
So I think there's a number of different threads of why wood is this, I believe, the essential tool to addressing both. One is obviously just choosing a material grown by the sun is essential, and I talk about that in my TED Talk, but also choosing a material that sequesters carbon instead of producing it in its manufacture is also essential. Wood buildings give us, especially in colder climates, give us a huge leg up in the energy performance of the building, which also creates an important opportunity. So those are kind of the quick hit list sustainable measures. Obviously, it's a material, by being grown by the sun, is rapidly renewable. It's got layers upon layers of environmental benefits in choosing it, as long as the wood comes from a well-sourced, responsibly sourced forestry practice. So again, that sort of shapes out a very quick snapshot of the environmental side. The affordable side is a kind of different story. It relates to the fact that affordability requires us to really reinvent the construction process to get rid of the enormous inefficiencies that exist in the way we make things, and especially to modernize the construction industry by moving away from sort of site-built solutions and into factory-built solutions. When you move into a factory, you can control the speed of things, you can control the amount of waste you produce, and you can control the cost. And that's, I believe, those are the essential steps for us to move to making buildings far, far more affordable and reach far more people. wood becomes a kind of essential part of building in a factory because its strength to weight is so much better than other materials. So if you built a steel building in a factory, it would be far too heavy to move the bigger pieces to the site and far too complicated to pre-assemble everything and then reassemble it on site. The same is true of concrete. It's just too heavy to be able to build off site. Light wood frame and light steel frame are possible materials to build off site, and they're quite good for building off site, but they're also quite rickety when you're building in a factory and then having to lift parts up that are built in light wood material or light steel material. They're quite flimsy to put on the truck to move them to site, and quite flimsy for the crane to put them on site. So mass timber is the sweet spot of a material that's both really sturdy, really robust, but also really relatively light and transportable. Meaning it's the material that I believe is the perfect solution to this shift in moving from site built to off site built construction that ultimately makes buildings far, far more affordable and ultimately also far more sustainable.
On that topic of sustainable forestry, if timber is really going to cut into the market share of concrete and steel, which already have a huge proportion of global greenhouse gas emissions, will our forests be able to sustain the volume of wood that will be required to supply such a big quantity of timber for construction?
I think the answer is yes, recognizing that it's not an overnight transformation of the industry. It's going to be a ramp in, and a number of steps are going to happen as we ramp wood into an increasing share of the market. One is that we're going to become much more efficient in the way we design with it so that we use less wood in a wood building than we do currently. Part of that is going to come from increased understanding of fire and structural capacity of wood buildings and moving building codes to being much more science-based than emotionally based as they are today. That will allow us to, again, reduce the amount of wood and still be able to do wood buildings that can compete with steel and concrete. One of the statistics that I really like is when we do a project, we quickly try to evaluate the length of time it takes the North American forest to grow enough wood to build that building. And when we built the first tall wood building in North America, it's called the Wood Innovation Design Center, we calculated that the North American forest grows enough wood for this 30-meter tall wood building every 4 minutes. And I think it really helps when you think you could grow a giant building in 4 minutes just by letting the forest grow. That's the beauty of a renewable resource, is it's constantly growing. And when you start to frame it that way, North America might be achieving a building like that, every day of the year, or several of those buildings every day of the year. But the forest has capacity here in North America to meet that demand if we manage it well. And I think there's a lot of room for innovation on, as I say, improving it structurally, thinking about how it mixes with other materials to increase its fire performance or its acoustic performance. Some of the reasons we overuse the quantity of wood right now are related to, really that we're in the infancy of a movement of understanding mass timber. And I think as the products innovate, we'll see just increasingly efficient use of it as a resource.
Mm. And it is one of the first times architects have really had a new material to use in a long time. And I think you mentioned that in your TED Talk also. So looking at the material first, what kind of different approaches should architects take with a timber first approach in mind?
Well, designing a timber building is a lot different because you're more engaged in the structural design than most architects typically are in their buildings. I think that's the important and fun part from a design point of view, that day one, you need to really understand the structural capacity of the material. You need to understand that it's obviously not a living material any longer, but it still behaves like a living material as it takes on moisture or dries out. It changes its character, and you have to design for that and understand that at the beginning of the design process. One of the other essential things is working with engineers that really understand the material and working and connecting with the companies that you might ultimately be building with, and engaging them early in the process to get their ideas and to get their technical know-how into your design. That's a lot different than the way architects design today. I mean, I think a lot of the way we design is to flip open catalogs or to flip through the internet to find building materials and not actually engage in where those materials come from or engage with those material manufacturers at the early stage of design. That's just not the way most architects work currently. But in wood, that is the way you have to work, and it's actually the real joy, because it returns to the way I think architects practiced 100 years ago, where we played a greater role in innovating with materials rather than simply buying materials off the shelf as we often do today. You need to have the right team in place that understands how it relates to local codes, that can engage with authorities having jurisdiction, that understands how mechanical, electrical systems might be integrated into the structural solution. Those are all really important. And so having an integrated design process, ideally with experts in wood already, is hugely advantageous.
So I understand Michael Green Architecture has recently teamed up with Katerra. So I'd like to just ask you, what was the thinking behind joining such a large company like Katerra, and what's the vision going forward?
So, I think, like you said at the outset, that the ambition that we've had as a practice has been to tackle more than just one building at a time, but instead to think about really the entire system of how we change the built environment to address climate and affordability issues. And what I saw in Katerra was, for the first time, a kind of Silicon Valley organization that was really thinking about our entire industry in a very different way, and willing to invest in innovation around answering those questions that we as a firm have always cared about. How do you build off-site? How do you do it more efficiently? How do you do it more affordably? How do you do it, more sustainably? And how do you bring software innovation, robotics innovation, machine learning innovation into the construction world to ultimately make the world, a better place? And I think those values were values I saw in Katerra when we were advising them. They're values that, since we've joined them, they've really continued to be very true for all of us. And I saw it as a chance for us to leverage what otherwise is our small company into having a much bigger global footprint in this conversation that we think is so important.
Mm. And you mentioned how one of the biggest values was efficiency. So, in thinking about efficiency, how can you achieve such greater efficiency, and what is that compared to what it's always been like in the past?
Well, it's funny. I'll use a funny analogy, but if you think about a residential project that has 300 toilets in serving 300 residences, right? The cost of a toilet is probably $8-9 at its origin in the manufacturer. But the way it works on the construction site is that before the toilet reaches the job site, it passes through, a distributor's hands, and then the subcontractor's hands, and then eventually the contractor, and then gets on site. Then the developer marks it up, and by the time the consumer gets the toilet in their bathroom, it's probably cost them $120. Well, that value shift for any product in the built environment is enormous, and there's no real value in it. It's simply passing hands. So when you start to rethink that, it means you start looking at vertically integrating a company that says, well, instead of that, why don't we build our own toilets? Why don't we make our toilets better, make them cost, maybe they cost $20 to manufacture, but now we can sell them to the consumer for $30, not $120. That's the kind of thinking that comes when you don't see the limitations of scale. And that kind of solution is the way you ultimately really invest in innovation, invest in more sustainable solutions, and can provide much more affordable solutions. That can apply to wood products, that can apply to lighting fixtures, or doorknobs or toilets, it doesn't matter. It's once you bring all of those things together, it has a massive impact on the cost of things. And, to really to make a more sustainable planet, it will always come down to being more cost effective than the alternative. People will not, I think, unfortunately, all history has shown us that people will not pay more for sustainable solutions, or the vast majority of people won't. So you have to find ways to make sustainability cost competitive. And that means rethinking, as I say, at scale, as Katerra's been doing.
Great. And you used a toilet as an example. What would it look like for, just say, a typical building, and what parts of the construction and design process are you looking to integrate to really drive these efficiencies?
Well, really to do it, you're talking every component of the project, right? If the structural system depends on the type of project, is 15 to 25% of the cost of the building, then you want to hone right into the structural solution. And that, of course, from our point of view, is shifting to wood and finding the most economical and elegant way to solve the problem in wood. But the structure itself remains only a fraction of the overall cost of the project. And so we wanted to take the story beyond wood and leverage our wood interest into this kind of bigger impact in the remaining, 80 to 75% to 85% of the cost of the project, which is again what we've been able to do with Katerra. As an engineer or any designer, you're ultimately liable for what you do. And so if you're looking at a beam or a column, you could spend a long time trying to shave away inches from the scale of that column to make it as efficient as possible. Or you could add 2 inches and know it's safe and not do a lot of engineering and take liability off your shoulders. That's all a product of a broken system. That's true, where a wasteful solution reduces risk and increases costs and increases environmental footprint, right? That is a perversion of the existing system that we have to fix. And I think this model of offsite, where you shift the thinking of the process, is the essential way you do that. Right now, the way the process works is that in the beginning of a project, you have a handful of people involved that are the designer and the engineer and maybe the developer. And by the time you're building it, there's this massive quantity of people involved, and they're trying to sort out all the issues that weren't resolved by the design team in the beginning. And they weren't there in the beginning of the process, so there's lots of ambiguity of what's been designed and how they actually build it. The way you fix all of that is instead by having the vast majority of the people, the contractors, the fabricators, the architects, the engineers, all working at the beginning of the project, as you do in manufacturing, all trying to answer every possible question before you make a product. By the time you make it and assemble it, the end of the process has very few people involved, because all of the good decision making has happened at the front end of the project, not at the back end. When you think that way, as they say, all manufacturing works that way, it means you resolve all of the questions of waste and cost and schedule, so that you know the impact of those things before you begin to actually make. That's really the only solution to solve all of these problems of ambiguity and waste that exist in the system today.
Great. And are you able to say if you've got one project fully designed, are you able to somehow take all that knowledge contained in that design and then use that for future projects as well, rather than designing the same thing multiple times, I guess?
Yeah, so one of the things that our practice that we really believe in is the idea that about half our work or less is bespoke projects, and the other half are typological projects. And if it falls into the typological project, in other words, if we're doing an office building in wood, we know we're going to do more office buildings in wood. And so the energy we spend on the first one is really planning to do many, many, many more, and to create a kind of template of how that would work. So anytime we're doing a custom project now, we're always trying to learn how it'll inform a typological project, how it'll make something that we could standardize. That doesn't mean that we think about this idea of creating cookie cutter buildings, that we design an office building that we're going to just copy and place all over the world. It's really not about that. It's about creating structural solutions or mechanical integration solutions or approaches to prefabricated curtain wall systems that are system solutions that can have different aesthetics but still fall within that system solution. So that, I think, is the other important thing about how design firms should evolve, is to thinking beyond the single project and really think about how it has a much bigger impact on other projects, not just within your own practice, but how you can share that information with other practices to kind of spread the message of a better way to build.
I like it. So you're saying you can achieve the performance and efficiency, or increase the performance and efficiency, but maintain the flexibility and choice. So what some kind of examples would you change for each project so you can maintain this flexibility?
Well, so I think one of the big fears that's existed for a long time of moving the building industry into offsite construction has been the idea that you start getting buildings that all look the same, that are cookie cutter, right? So the difference is, I often use the analogy of how the car industry works. In the car industry, it used to be if you went into a factory with people installing doors on cars, you would have the exact same model of car going down the assembly line, because humans really don't have a lot of flexible ability to install different doors. They want to do all these repetitive actions. Today, if you go to a car manufacturer, every car down the assembly line can be a different car because a robot is installing the parts, and the robot actually is much more sophisticated and can actually do many more diverse things than a human. That's the transition, is that we're moving to what we call mass customization, and away from mass production, which is what people fear when we talk about offsite construction. Mass customization means it may be that you're building a curtain wall system that allows you to prefabricate an entire exterior envelope in huge panels and then deliver those panels to site. So the concept is basically that you can mass customize. So what you want to do from a design point of view is you always want to design for a specific neighborhood. You want to look at your contextual neighbors in the neighborhood so that the building fits in. You want to look at the regional issues of climate and geography and the local issues of topography. You want to look at cultural impacts of the region as well that reflect in the building design. What the history and the vernacular are of the region. There's all these layers that really say to us as designers, buildings need to look different. They can't all look the same. They really are appropriate if they're designed for their place and not this kind of random catalog where you're just going to throw them on a site and not think about it. You can still do that in this mass customization model. In fact, you can do it really well in the mass customization model when you build these framework systems of structures or envelope systems or, pod style bathrooms, kitchens, things like that. You can still create this really custom building that fits all those unique needs because it's being built by, effectively in a more robotics model like the modern car factory.
I'd like for you to just delve a little bit deeper into the role of robotics and what level of robotics you've got in the factories you're working with, and the speed of innovation in the robotics and how that might influence how things are built going forward.
Mm-hmm. Well, so one of the shifts that we're in Katerra, I think, moving to is the idea that, much like manufacturing, every component of a building should have an RF code so that you can, effectively every piece of a building has a component, a searchable component quality to it. So you know what it cost, where it was made, what its dimensions are, what its weight is, what its carbon footprint is, what its energy footprint. All of that is embedded within every single material, whether you're talking about a screw, and you know exactly how many screws go into the building, or, a CLT panel. You know exactly how many go into the building. In a kind of fully integrated construction process, it means that as I design, I'm not drawing walls, I'm drawing parts. When I'm doing that, I actually can see the real-time cost of the building. As I design, I can see the real-time environmental footprint of the building. I can see even schedule impact of the building happening, not yet in real time, but eventually we'll get to real time as I design.
So if you want to learn more about timber yourself and upskill, I suggest that you go to the Wood Solutions website to check out all the technical design guides. Right now there is 47 of them. One of the most recent ones, guide number 46, Wood Construction Systems, being a very good start for the conceptual design of timber buildings. And by the way, I've left a link to Michael Green's TED Talk on YouTube, which is in the show notes.